Halloween. I did not see that coming.
Guys, it's snowing, so I think we should go to a warmer area and work on some area formulas, okay? Hi guys, so the very first thing that you guys need to do is you need to go around your home and you need to locate some items. All right, so here are items that you need. You need items in these shapes. Are you ready? Okay, here we go. You need something in the shape of a circle, parallelogram, triangle, trapezoid, a regular polygon, so like a hexagon or a pentagon or octagon or something, a kite or a rhombus, and then of course a ruler because you need to measure these things. Okay, so do the best that you can to find these items. Okay, if you can't find something, it's okay. Just try to find as many as possible. All right, and go. Don't all get it up at once. Okay, and go. You too. Go find the stuff. Hi guys, did you find everything? So I'll just show you what I have here. I have my circle, beautiful gold platter that you can see through. I have my rectangle, which I will cut into a triangle. I have my regular polygon, got an octagon, and I have my kite, and I couldn't find a trapezoid, so I'm going to make one out of this piece of bread. Okay, so let's start easy. Let's go with our parallelogram, and in my case it is a rectangle. My base is 11 inches. My height is 8.5 inches. Okay, and so the area of a rectangle is equal to the base times the height. Okay, and in this case, my base is 11. My height is 8.5. Okay, and so we're going to do the multiplication, and when you multiply you should get 93.5 inches squared. Okay, that is the area of my parallelogram or rectangle. All right, so here's my rectangle again, and I have made a cut right here, and I'm going to take this triangle and slide it over here, and you'll see that that still makes it's still the same area, right? All I did was I slid part of it over, so it should still have the same area. Okay, but now this looks more like the kind of parallelogram that you know. Okay, but if I took this base, which was 11, and I moved this piece over here, this base is still 11 inches, okay, from here to here, just that this piece is moved over here, and the height is still 8.5 inches. Okay, so it's still the same dimensions. You still take base times height. Okay, so the base and the height in a parallelogram, they're whatever two pieces make a right angle. Okay, those are the two pieces that you use. Okay, so area of parallelogram, base times height. What I'd like you guys to do after I show you each of mine, I would like you guys to find yours. Okay, so that'll be a nice practice for you to find the area of your figures. All right, I'm going to use my triangle that I just cut off of my parallelogram, and that is what that's what I'm going to use for my triangle. So for the area of a triangle, it's actually going to be half of the area of a rectangle. Okay, so you can say half times base times height, or you can say base times height divided by 2. Okay, that's the formula for the area of a triangle. Okay, my triangle, okay, my height is 8.5 inches and my base is 3 inches. Okay, so here is my triangle. Okay, and so if I look at my formula here, I'm going to take 8.5 times 3 and divide it by 2. Okay, so that's 25.5 divided by 2, or 12.75 square inches. Okay, so here is my triangle, and if I put another identical triangle right here, it makes a rectangle, but my triangle is half of the rectangle. So that's why we take half. Next, I have my circle. Okay, and I have found the radius of this circle. It's 8 inches. Okay, remember the radius is from the center out to a point on the circle. Okay, so the center to any point on the circle is called the radius, and I found that mine is 8 inches. And we are going to find not only the area, but the circumference. All right, so for the circumference of a circle, the formula is 2 times pi times the radius, or diameter times pi. Okay, and I'm going to show you why here. Luckily I had this kite string here from my kite, and I wrapped the string around my circle to get the circumference. Okay, and I marked it right here. Okay, so now what I'm going to do is I'm going to take my string. I've marked it right here. This was basically from here to here is the circumference of the circle. Okay, and so I wrapped it around the circle, and I'm going to show you on here how many times the diameter will go into that circumference. Okay, so here is one diameter of that string. Okay, and here is 2 diameters of my circle, and here is 3. Okay, and then I have this little bit left at the end. Okay, so a little bit more than 3 times the diameter. Why, the circumference is basically the diameter times pi. Okay, pi is approximately 3.14, so it's a little more than 3 times the diameter. If I do the calculations, we're going to take 2 times pi times the radius, or 2 times pi times 8, which is 16 pi. And so if it says to write your answer in terms of pi, you would write 16 pi inches. Okay, or approximately 50.27 inches. And that's rounded to the nearest hundredth. Okay, so that's the circumference of this circle. And for the area of a circle, I always say that the area formula is a lie because it's pi r squared, but pi r not squared, pi r round. Actually, my daughter made me a pie yesterday. She had to include the pi symbol. It was quite tasty. But pi r round, not squared. So all we have to do is plug in the radius, so pi times 8 squared, or 64 pi square inches, which is approximately 201.06 square inches. All right, so I couldn't find a trapezoid, so we are going to use this lovely piece of bread to make a trapezoid. All right. Here is my trapezoid. All right, so the formula for the area of a trapezoid is this. You take the 2 bases, you add them together, you multiply by the height, and you divide by 2. And I'm going to show you why that is the case. Okay, so basically what you do is you take the, basically it's the average of the bases times the height. So the average of the bases would be in the middle of the two bases. So like right here, I'm not gonna eat this, it's okay. And right here. Okay, so that's like the average of the bases. And I'm gonna draw a rectangle that is the average of the two bases. Okay, so this rectangle that goes, that's the rectangle. If you look at this, so that is a rectangle that's the average of the bases times the height. So if I were to take this piece and go, and I'm gonna put it right here. Here it goes. Okay, and then I'm going to take this little piece and I kind of stretched it out when I pulled it up, so it's not exact. And then I put it right here. There's my rectangle. Okay, and so that is the average of the base times the height, and I realize that it's not perfect, but that's the basic idea. Okay, so here is the area of my trapezoid that I had. Okay, so the base is 5. The first base is 5.
I want juice and Chase wants swaddle. And
Okay. And the other base is 4 inches, and the height is 3 inches.
Mommy.
Okay, so I'm gonna take. Okay, I'll get you a regular cup. Just a moment. Okay, so we're gonna take the two bases. I'm gonna take, and here comes the dog. We're gonna take our two bases and add them together. So whoops, I'm thinking of too many things at once. My two bases, I've got 4 plus 5, and I'm gonna multiply that times the height, and then divide by 2. So basically it's the average of the bases, so 4 plus 5 divided by 2 is gonna be my average, so 4.5 times 3. Okay, so we get 27 divided by 2, or 4.5 times 3.
We are doing it downstairs.
Okay.
Mommy,
And so that would be 13.5 inches squared. And that is the area of my trapezoid piece of bread. And I think I need to go get someone a beverage. And here is my kite. Okay, and I am just going to use the part that actually makes the kite shape with the little poles. But this kite has had quite the adventure during this break. It got stuck in a tree, and then a windstorm carried it to a different tree and a different tree, and finally it was rescued. So this is a very special kite. But the area of a kite is the same formula as the area of a rhombus. Okay, so you're gonna take your two diagonals, D1 and D2, those are your two diagonals. So if you look, this is a kite right here. Okay, so here's one diagonal. These are like the poles that go inside the kite. Okay, so diagonal 1, diagonal 2, you multiply them and then divide by 2. Okay, and the reason you divide by 2, I'm just gonna show you why this formula works the way that it works. Okay, because here's one diagonal, and that's the distance across the kite. And then the other diagonal. So if I just took diagonal 1 times diagonal 2, it'd be like, this is diagonal 1, this is diagonal 2. I would find the area of this whole rectangle. Okay, but this little piece is half of this rectangle, this little piece is half of this rectangle, same with this one and this one. So the kite is actually half of that rectangle. So that's why you divide by 2. And the same works for a rhombus. So for my kite, my two diagonals are 18 inches and 24 inches. And so I multiply them together, divide by 2, and I get 216 square inches. And finally, I have my octagon, my clock. Okay, so It's okay that I drew on this because I haven't used this in years, but it still works for some reason. Okay, so we're gonna find the area of this octagon, okay? And so the easiest way, I believe, to do this is to find the area of one triangle and then look and see that we will have one triangle for every side that this figure has. So there will be 8 triangles. So if we find the area of one triangle and multiply by 8, that will give us the area of this octagon. Okay, sounds simple. Oh, I forgot to tell you a couple things. All right, so from the center to a point of vertex on the octagon, that's called a radius. And from the center perpendicular to one of the sides, that's called the apothum. Okay, so just a couple of vocabulary words for you. All right, so to find the area of a regular polygon, we're gonna use this piece, okay? And so I'm just gonna take this triangle and I'm gonna put it over here. Remember, this is called the apothum. It's 6 inches, okay? And it would be really easy if we had the base and the height and we could just find the area of the triangle just like that and multiply by 8, but we're gonna make it a little more tricky, okay? I could just measure it, but nah, we like a challenge. Okay, so I'm only gonna give you that figure, okay? And so we get to use a little bit of trig to figure this out. The first thing we need to look at is the central angle, okay? And the central angle is this angle inside here, okay? And since the whole thing is 360, we're gonna divide 360 by 8 to figure out just that angle, okay? And so we do that and we get 45 degrees for our central angle. So after we have found that central angle to be 45 degrees, we're going to take just a right triangle because we're going to end up using trig, okay? But if we take the right triangle, we have to take half of that 45, which is 22.5, okay? We don't know, this you didn't know before, but we don't know the base of this triangle. The only information we were given was that the apothum was 6 inches. Okay, so we need to find this piece. Okay, and so in order to find that piece, we've got this piece which is the opposite and this piece which is the adjacent. Okay, and so we're gonna have to use tangent. So we're gonna say the tangent of 22.5 is equal to opposite over adjacent, or x over 6. And then if you type that into your calculator, remember if x is in the numerator, you're gonna multiply. So we're gonna take 6 times the tangent of 22.5. We get x is approximately equal to 2.5. Okay, so if the base of this right triangle is 2.5, then that means each one of these two is 2.5. So the whole base of this triangle is 5 inches. All right, so that triangle that's on this clock, the base is 5 inches approximately, and the height is 6. So to find that triangle, we're gonna take 5 times 6, divide by 2, and we get 15 square inches for each one of those triangles. But again, remember there are 8 of those. So we have to take that times 8. And so if we take 15 times 8, we get 120 square inches. And now for a twist. All right, so we have a trapezoid here, okay? And we are going to find the height of this trapezoid because we know the area of this trapezoid is 2,200 square inches. And the base of this trapezoid, base 1, the longest base of this trapezoid is 5 feet, or how many inches? 60 inches. And then base 2, what is your height? 50 inches, 4'2". Okay, all right, so given that we know the area and we know the length of the 2 bases, we are going to find the height of this trapezoid. I know that my area is 2,200. My base 1 said that her height was 5 feet, or 60 inches. my base 2 said that her height was 4'2" or 50 inches. We don't know the height, and then we're going to divide that by 2. Okay, so a couple ways we could do this. We could add 60 plus 50 and divide by 2, or we could multiply both sides by 2, which I think most of you would probably do that first just to get rid of that 2. So I'm going to multiply both sides of this equation by 2, and so then I get 4,400. And then my 2's will cancel, so then I get 60 plus 50h, and 60 plus 50 is 110. Okay, and so then I get 4,400 is equal to 110h, and so then I'm going to divide by 110. Okay, and so then that makes the height of my trapezoid 40 inches. And that is correct because I measured with the height of one of my children, which is 40 inches. Sometimes we will have to use the things that we know to find the thing that we don't know. And in this case, we didn't know the height, but we knew the area. So we found that piece we didn't know. Good job.
This video took so long that the snow's gone. I think we should go outside for our next lesson.